Hi, hello everybody. So this is the video dealing with section 4.6, graphs about the trigonometric functions, and this is the second part where we cover the cotangent function. Now it's very similar to the tangent function, so if you remember how the tangent looks like, this is the graph of the cotangent right here, and just like the tangent, it's a periodic function. The tangent is the blue graph. The dashed line are the asymptotes, and the tangent look like this. So it looks like a reflection, not going over the 3 pi over 2 um, x-intercept, but it's a reflection, looks like a reflection on the tangent. So we are going to be graphing a cotangent that looks like this format. It's identical to the tangent. The A represents the either stretch or shrink. We're only interested in if A is positive, then the cotangent will look like this, the regular cotangent. And if A is negative, it's a reflection. So the cotangent will look like that, which is almost identical to the tangent function. Okay, the only difference that we're going to implement a slightly different approach to graph the cotangent. The period is pi, as you can see here, but it varies from 0 to pi instead of pi over 2, negative pi over 2 to pi over 2, because cotangent is undefined at 0 and pi, because for example, cotangent of 0 is 1 over tangent of 0, and tangent of 0 is 0. So obviously cotangent of 0 is undefined, but as it approaches 0, we get one of the asymptotes, and as approach the pi, we get the other asymptote. Okay, so with the tangent case, we were able to immediately find the x-intercept by making bx minus c equals to 0, but in the case of the cotangent, we can't do it for the reasons I just mentioned here. So what we're going to do is we're going to find the vertical asymptotes first, and then we're going to find the x-intercept after by using the fact that the x-intercept is midway or the midpoint between the left asymptote and the right vertical asymptote. Okay, so that's the only difference. Other than that, it's exactly the same. Okay, so let's take a look at the two examples that I have here for us. All right, so let's just scroll this up a little bit and make it a little bit smaller. All right, I'm gonna move this over here. Okay, now let's take a look at the first example. Again, we're not interested into the amount of dilation here. In this case is 3. We can't see it from the graph. We can barely see it with software. We just are interested in the fact that it is positive, which means I'm going to have a regular cotangent. Okay, so the two dashed lines that you see here are the asymptote. This is going to be my x-intercept, which I'm going to find last. So the equation of the vertical asymptote, I don't have it yet, but I'm going to write it over here. And I know that A is greater than 0, so I have a regular cotangent as you see up there. So I'm going to graph it this way. Now, remember that you have to graph the tangent or cotangent approaching the asymptote lines, right? So they cannot be far away. They have to be an indication that they are approaching, but never crossing and never touching. So this is what the cotangent will look like. And now I have to find the two vertical asymptotes. So to do that, I am going to solve two equations. 2x minus pi equals 0. And I'm sorry, 2x minus 4 pi over 4 equals 0, and 2x minus 4 over pi equals pi, because that's where the location of the two vertical asymptotes will be. So in the left equation, I just add pi over 4 on both sides. right? They cancel here. I get 2x equals pi over 4. And then I divide both sides by 2. And I get, this is the left asymptote because 0 is smaller than pi. So equation of the left asymptote, pi over 8. Now let's solve the other equation, same as before, pi over 4 on both sides. Now I have pi plus pi over 4. I find a common denominator, which happens to be 4. I adjust the numerator. So I have 4 pi over 4 plus pi over 4, which is obviously 5 pi over 4. And then again, I divide both sides by 2. I get 5 pi over 8. And that is my right asymptote, 5 pi over 8. Okay? Now remember, the equation of the asymptote is an equation. So you're going to write x equals whatever number you found. Okay? As I did over here. Okay, so I have my two asymptotes. Now I have to find the x-intercept, which is right here. Okay, now to do that, all I have to do, I'm going to erase this a little bit. All I have to do is find the midpoint between the asymptotes. So this is my x-intercept, which is the midpoint. So how do I find midpoint? So right asymptote plus left asymptote divide by 2. So this is obviously 6 pi over 8. All right, which is 3 pi over 4 divided by 2, which is obviously 3 pi over 8. Okay, so this is the location of 3 pi over 8. Okay, and we can verify that, right? We can verify that by replacing 3 pi over 8 here and confirming that we have a asymptote at that point. So 2 times 3 pi over 8 is 6 pi over 8. 6 pi over 8 minus pi over 4. Obviously, 6 pi over 8, if you simplify the fraction, is 3 pi over 4 minus pi over 4, which is obviously 2 pi over 4, which is obviously pi over 2. Now, cotangent of pi over 2 is 1 over tangent of pi over 2. And we know that this is going toward infinity, so this is approaching 0. So this is okay, this is correct. And we have the graph of our first cotangent. Okay? We won't need these points right here. All right, I don't need you to graph that. I just need you to find the two vertical asymptotes and the x-intercept in the middle. All right, that's the first case. Now, the other one is identically the same. I'm going to erase all of this. So if you want, you can obviously stop the video. But the only difference is now that A is negative. Now, if A is negative, I have the exact reflection of the basic cotangent. So I'm going to graph this way. All right, so let me do it again because unfortunately on this thing, it's very, very difficult to do. Now, remember that you have to have the lines or the function approaching the vertical asymptotes. And I'm going to put the information here, and then all I need to do left is find the x-intercept. Okay, so with the cotangent, I find the vertical asymptotes first by equating the angle information with two equations, first to 0, that would be the left asymptote, and then 3x minus 2 pi equals pi, and that will be the right asymptote. And I just solved these two equations, so that's very easy. I add 2 pi to both sides. And then I divide everything by 3. And that is the left asymptote. X equals 2 pi over 3. And I do the same for the right equation. 2 pi on both sides. 3x equals 3 pi. And then we divide everything by 3 and we get pi. Okay. Okay, so one asymptote is 2 pi over 3. The other is pi. And now all I have to do is I have to find the midpoint between the two, which would be the x-intercept. So that's very easy to do. X-intercept, I will have pi plus 2 pi over 3. And then we're going to divide by 2 after, right? So find a common denominator. So that would be 3 pi over 3 plus 2 pi over 3, or 5 pi over 3. And then we divide it by 2, which is obviously 5 pi over 6. Okay? So this will be the location 5 pi over 6. And we can check that again, that this is a x-intercept. I'm going to erase this real quick. And we can check that rather fast. The cotangent of 3, and then replace x with your 5 pi over 6 minus 2 pi is your x-intercept. So this will be 15 pi over 6, or if you can, reduce the fraction, right? 5 pi over 2. 5 pi over 2 minus 2 pi. We can find the common denominator, right? And then multiply the denominator by 2, multiply the numerator by 2. So this is cotangent of 5 pi over 2 minus 4 pi over 2, or cotangent of pi over 2, which is again the same as we had before. This is 1 over tangent of pi over 2, but tangent of pi over 2 approaches infinity. So 1 over tangent approaches 0. So this is okay, which means that our 5 pi over 6 is our x-intercept. So this is how you would graph the the cotangent that has a negative a, right? The negative a is a reflection of the regular cotangent. And those are the only 3 points that you need. You need the left vertical asymptote, the right vertical asymptote, and then the x-intercept.